Hi, Victoria. Nice picture.
Oh, thank you. Yeah, nice, sad but important picture.
Yeah, it is.
Nice to see you.
Hi,
Hello,
Adam.
Adam.
To unmute, there's all the way on the bottom right, there's a little microphone symbol. If you
Oh, I
click on
see.
that. Yep.
Got it.
Perfect.
Can you hear me now?
It worked. Yep. So if
Excellent.
you want to check out really quick how the audience sees your slides, on top you see the slides posted as a link. So click on it and it says go to link, and then people can then see your slides and scroll through them. So when you switch slides, it's really helpful to mention it.
Okay.
You're switching.
Okie dokie. And then is the camera on? Am I seeing the people? Do people see me? How does this work?
Oh, we see you. We see everything. Like we got a webcam installed.
No.
Okay.
It's just audio.
Oh, it's just audio.
And
Okay.
relax, walk around.
Oh,
Sit on
excellent.
the
Yeah.
couch.
Curlers in
Be in
your
pajamas.
Oh, this is. Can I play video games while I'm
Do
doing
it.
this? Because
Yeah.
that's my standard. Whenever I'm on a meeting, usually I'm not talking, but whenever I'm on a meeting, I don't really want to pay attention to. I just play video games while I'm on it. Don't tell anyone I said that, though.
No, it's a secret.
Recorded
Good,
for
good,
posterity. But Adam, if you'd like, you can put a photo in place of your initials, which are also lovely, but your choice. Maybe you get like a live.
Where does
If
it?
you do a long press on your biopic, which is your initials right there with the little party.
I don't see my initials.
So okay. What do you see on the screen? Do you see Katarina and then
I see Katarina and I see Science Society, Dr. Frank, and then I don't see anything that I don't see anything that indicates me.
Are you on Club Deck?
I'm on. Who the heck knows?
Are you on? Are you on?
Oh wait, there is a down at the lower right. Okay, so I can add a picture, but I don't even have any pictures on my. I don't know what.
Well, you
picture
can
I'd add.
download some.
Okay,
I mean, there's no pressure. It's just fun if it is a fun thing, or you can get something off the internet, or take a screenshot of your work or anything. It's a free expression.
Okay, there we go. I just looked up. There we go. I'm done. Okay, that's me. Bum ba dum bum. All right. Okay, so now
we are.
Now I'm a person.
Yeah, like for future use, if you want to use Clubhouse, in the future, it's helpful to have like some information and a picture, so people know you're an actual human and not just a bot that comes.
Right. I'm going to be honest. I probably, unless somebody makes me use this, I won't be using this software. It's like I have too much software in my life. But at least now I know in case anybody else wants me to use Clubhouse.
Well, you might want to come back, Adam. That's
another possibility. Sure, that can definitely.
We hope.
So what is your group? Tell me more about your group while we're setting up, and then in the minute we have.
Yeah, so it's a mixed story of Clubhouse itself. It started kind of during COVID. People were shut down at home, and then this app started. Used to be invitation only, so people would like it. It became to be like a close-knit community in the beginning, with a lot of conversations about everything. And when I joined, which was a little bit later and like not right in the beginning, people used to ask me a lot about scientific stuff, and just because I was a scientist doesn't mean I know about science in general.
Right.
So I started inviting people to give more of an expert answer instead of me live Googling and reading really quick and then giving an answer. And then it started into a thing, and then I created this club where I where we do this as a group in general. Like,
That's great.
I'll share suggestions, or I read like articles, in the
Right,
news,
right.
and then I look at the paper, and then I invite the actual people that did the work. Because in the beginning, sometimes journalists would share, and I felt very often it was relatively incorrectly with the little I even knew about some scientific fields. I kind of figured that it was not really 100% correct all the time. So yeah, I started inviting the actual scientists, and
Right, right. To go
now
talk
there are a
about it.
few more clubs that are doing this. So that kind of do a mix of popular science news journalists and researchers, but I try to keep it just researchers, because I don't want people that are not scientists to kind of get mixed up, like
Right.
this person is just as reliable the information as this person. And in a lot of fields I can just tell if people are talking nonsense or not, so I rely on just inviting the people that wrote the
Consent.
paper.
Yeah,
And
right, right.
it's just I need to do less fact checking. That's so this is, and then people gave really good feedback, and it's a really mixed audience. And some
Cool.
people even started going back to school because of our club.
Because
They
of the,
wrote us.
what a great outcome.
Yeah, like because it felt very different to regular academia learning. They kind of got motivated to learn by themselves about stuff. And then went back to school and stuff. So yeah,
Cool. Okay.
it's been really nice.
All righty.
Okay, I think we can start. So
Okay.
I apologize in advance. Yesterday, I kind of started getting a huge coughing attack. So if that happens, Victoria is here today to help out. It was very awkward. I had to like mute and get honey and stuff. So I hope it doesn't happen today. But Victoria's here.
Yeah, I'll have to send you some lozenges. There's some honey lozenges I keep on hand.
Oh, yeah, I
Yeah.
don't know.
Is it-
I didn't have anything. Like, the whole day I was fine, and then at night I started, like, while I was talking, every time I started talking, I couldn't stop coughing. Anyhow, welcome everyone to Science Society, and of course, a special welcome to Adam here. And before we start, I know people will continue coming in, but before we start, I want you to introduce Adam here to everyone so you get to know him a little bit better. And then Victoria will ask a few interview questions, Adam, if that's okay with you,
Sure.
to get to know you even a little bit more. So, Dr. Adam Frank, he's an astrophysicist and he's a leading expert on the final stages of evolution for stars like the sun. And his research group is a computational research group who has developed advanced supercomputer tools for studying how stars form and how planets evolve. And his current work focuses on life in the universe and the search for technosignatures of other exocivilizations, along with climate change and the astrobiology of the Anthropocene. Sorry. So he describes himself as an evangelist of science, and he's very committed to show others the beauty and power of science and exploring the proper context of science and culture. You should really check out his latest book, Light of the Stars, Alien Worlds, and the Fate of the Earth, that got praise from the New York Times, NPR, and Scientific American. And then he also wrote two other books, The Constant Fire, Beyond Religion and Science Debate, and About Time, Cosmology and Culture at the Twilight of the Big Bang. And Adam is currently finishing his next book, The Little Book of Aliens, to be published soon, next year. And Adam is also a regular on-air commentator for CNN and for NPR. in All Things Considered. Um, and he was a co-founder of the National Public Radio 13.7 Cosmos and Culture blog, which he ran for 7 years. And he is also a regular contributor to the New York Times, Atlantic, and other media outlets. And he also runs a 13.8 blog on bigthink.com. He was a scientific consultant and different shows. He was on the Joe Rogan show, and he received many awards, including awards for his scientific and outreach work. And his latest book won the National Honor Society Best Book in Science Award. So yeah, I could go on and on for hours, probably talking about your work and your achievements and everything, but we
But then
kind
you'd
of
sound like my mom.
that, which is fine. I'm a
He's
mom.
an
I have 3 kids.
astrophysicist. He's such a nice boy.
I have 3 kids, so I get it. But Victoria usually does a really wonderful job at interviewing our guest speakers.
Thank
So
you.
let's do it that way. Thank
Another
you.
mom. So, Adam, let's start with breakfast. Did you have it? No, I'm just kidding.
I did, Mom.
Okay. Restart. So,
Okay.
welcome, Adam. Yeah, thank you, Katarina. We are so happy to have you here in Science Society today. So, my question can be considered specific to your work or science in general. It is, I'd like to know if you can tell us about your remembrance of your entry point into science or your first initial spark. And so that question can be applied to you as a child or anywhere along your life.
Okay. So I was 5 years old, and I was in my dad's library, in front of all of his books. And I pulled out. He really was into pulp science fiction, like amazing stories and Isaac Asimov's, astounding worlds. And I was looking at the cover of one of them, which had like a guy in a spacesuit on like the jagged mountains of an alien planet, and that was it. I was just like, that's it for me, man. That's what I want to know about. And so I've never really had there's never been anything I've ever wanted to do other than that. I actually really wanted to be a space pirate, but that's not an option for me. So I became an astrophysicist.
I'm sure we're all glad that you decided to tread the straight and narrow.
I want to be a space pirate.
Well, maybe you are in your own way, in your own interpretation of
Oh,
space
there we go.
pirate. Yeah, that's great. I would also imagine that many of us can remember being in a very special library. I had that as well in my house, and some pretty amazing books that my mom
Yeah.
and they were just like friends.
Right.
You just spent a lot of time with them, and so from that childhood time, maybe you can take us along in leaps, a path up to the current work that you're going to present with us today.
Yeah, so I was read a lot of science and philosophy. I have a strong interest in philosophy. Going through high school, discovered that actually I really loved the theoretical side. Not the looking through telescopes. I was no good at that. So got into college, focused on. I got a degree in mathematical physics or math and physics. And so that was undergraduate at University of Colorado, graduate at the University of Washington in Seattle, and there is where I got turned on to fluid dynamics and computational fluid dynamics. So I ended up, the bulk of my career was developing advanced computer programs for doing supercomputer simulations of things like star formation and stellar death. But I was always interested. I mean, the question of life was always paramount for me, like the existence of life anywhere else. This fundamental question of, are we the only time in the entire and place in the entire universe that this very strange thing we called life has occurred, was always on my mind. So as the astrobiology revolution occurred in the 90s and the early 2000s, which was really centered on the discovery of exoplanets. We started discovering planets orbiting other stars, and we didn't know whether there were any before 1995. That I really started shifting my work towards the question about life and planets. And so I got started thinking about climate change as kind of an astrobiological phenomena, and that was what my last book was about. But that took me to thinking about, just in general, how planets and life will evolve over billions of years. And particularly, I've always been a big fan of what is called the Gaia hypothesis, that, life hijacks planets. And so that is one of the, these days I'm working on I have a NASA grant to study technosignatures, how you might find, evidence of civilizations, or at least technological deploying life elsewhere in the universe. But I'm also very interested in just the theoretical foundations of what life is. And again, how biospheres and technospheres interact with the geospheres over long periods of, billions of years. So that's kind of the work I'm going to be showing you today.
Well, then we can't wait. So thank you. It really just, it's like opens up the research and leads us into that when we can hear your background, which
Right.
Thank you for all the details. So at this point, I will pass the mic back to you, and you can deliver your talk, and you see that you have your work is at the top so people can follow along. And then if you'd like to have a Q&A following your discussion or along the way, that's up to you. And sometimes people will put questions in the room chat, which we can share with you as well. So all you need to do is enjoy gaming and talking. Your work, make sure you have water. All right. Thank you so much.
Sure. Okay, so I'm going to go, I have until 10 to 3 when I have to go to a talk. Actually be physically present at a talk. So what I'm going to do is I'll probably just spend the next 20 minutes kind of, lightly going through these slides, just to give you everyone an idea of what this idea is. And then, let's spend 20 minutes talking, doing questions and answers. So the idea here is planetary intelligence. So that's my opening slide. I did this work with David Grinspoon and Sarah Walker, who are both astrobiologists. And so let's go to the next slide, because this is the fundamental question: who and what has intelligence? And the idea is that, conventionally, when we think about this, intelligence is a property that individuals have, like certainly adorable little babies have it, and maybe adorable dolphins have it. But we also recognize that, there's the possibility of collective intelligence as well. So social insects have, make incredible decisions and choices, not as individuals, but as a collective unit. In many ways, you have to think of the ant colony or the bee hive as being the organism, not the individual ants or bees. So, when we think about intelligence, it's not just something that necessarily sits in heads on shoulders, but may be distributed. All right, so if we go to the next slide then. So, one of the really amazing developments over the last 20 years in this study is the recognition that systems that we didn't used to think had intelligence, and by intelligence here, we'll talk a little bit more what we mean, but we're not necessarily thinking thoughts in a head. We're not thinking necessarily self-consciousness, but we're thinking about the ability to cognize, to recognize things that are happening in the environment and to respond to those things in the environment, perhaps in ways that, demonstrate awareness, a deeper awareness of the place in the environment. So, the best example I really love of this is trees. The discovery of what are called, if I'm pronouncing this correctly, mycorrhizal networks, the fungal networks that link the root systems of trees. And they essentially mean that forests that can stretch across hundreds of miles are kind of all linked. It's like, people talk about the idea of a green mind. Whereas if one part of the forest is stressed, doesn't have, the resources, the other parts of the forest, through the mycorrhizal network, recognize it and will send that part of the forest aid, the resources it needs. Also, we know now that bacteria do what's called quorum sensing. the bacterial colonies are aware of their environments and will respond to their environments. Slime molds can solve puzzles, can solve mazes. So, all of this idea of collective intelligence, and the idea that also, intelligence can be distributed quite a bit across space and time, leads us to the idea that intelligence, broadly construed, right? Again, I'm not talking about self-conscious, thinking philosophical thoughts in your head. I think we now have good evidence that it operates across diverse length and time scales. And so the question that we were asking in this paper is, can intelligence operate at a planetary scale, on scales across an entire world? And if so, how does that happen? How do you make a transition from just, individual organisms to something like planetary intelligence? So the idea here would be that, and this is something that goes back to like the Gaia hypothesis, the idea, and this is, we'll talk about this, but I think we really now recognize that life is not just something that happens on a planet, it happens to a planet. Like once life forms and becomes robust enough on a world, then the history of that world is forever changed. Okay. Life is not just some green scruff that's sitting on the surface of the world. It completely alters the functions of what we call the coupled planetary systems: atmosphere, hydrosphere, cryosphere, the ice, and the lithosphere, the surface. So the question here is intelligence the same thing? Is intelligence something that does not just occur on a planet, but happens to a planet, altering the planet's history? So if we go to the next slide now. So you might ask, well, why do you even want to ask this question? And you want to do it for actually three specific, this concept of planetary intelligence may prove useful for three distinct domains. And the first of these is Earth systems and exoplanet studies. And that's just, we are studying, we have all these planets. We're going to see there's all these planets we've discovered. We now know that every star in the sky has a family of worlds orbiting it. And we're very interested in whether or not those planets have life on them. And this idea of planetary intelligence is relevant to that because we want to know how that intelligence involves, or we want to know how the life involves. And if there is intelligence, how does that intelligence evolve and change the planet's trajectory? So the idea that we have lots of planets to study now means we want to understand how planets and life evolve together. And that's the same thing for the Earth. If we look back at Earth's deep history, the biosphere has been around for at least a couple of billion years, if not 3 billion years. And how has Earth's history been shaped by life and perhaps by this idea of a planetary intelligence? And then, so those are two, Earth systems and exoplanet studies. And then the other why we're interested in this is the Anthropocene and sustainability studies. Like it's clear that right now the Earth is in this very weird moment where there is one species, us, that is severely altering and very rapidly altering the function of the coupled systems. Again, the atmosphere, oceans, ice, ground. And so that's what the people call this the Anthropocene, the human-dominated era, or or epoch of Earth's history. And so to understand that better, like not only what's happening, but how might we also, deal with it? How might we kind of come out the other side intact? So, so this question of planetary intelligence is going to be relevant to Earth's history. It's going to be relevant to Earth's history now, or what we face now. And it's also going to be relevant towards thinking about other planets in the universe and looking for life there. Okay, so some historical preliminaries. So the idea of the biosphere and what the technosphere, which is, so the biosphere is total of life on the Earth. The technosphere now is the sum total of our technological systems. But these ideas go back a ways, actually. The biosphere was first introduced by the great Russian biogeochemophysicist, Vladimir Vernadsky, who is not very well known in the West, but probably deserves to be up there with Einstein and Darwin in terms of his recognition of the role that life plays in planetary history. So the idea of the biosphere was Vernadsky. He had already anticipated the idea that our technology is becoming so powerful that it is going to be another layer that is going to be wrap around the planet and alter the planet's function. And then out of that, via James Lovelock and Lynn Margulis, was the idea of Gaia. That if you looked at the biosphere, you should look at the Earth as being, almost in a sense, a living entity, right? That life hijacks the planet for its own ends. And so the Gaia hypothesis was that the life through these can just really take over the Earth's functions, and can do things like keep the Earth at a reasonable temperature, even though the sun is continually heating up. That the Earth, life will keep the Earth in conditions, climate, etc., conditions that keep the Earth habitable for life. So these are historical preliminaries that we're going to lean on. So if we go to the next slide, this is a little bit more about the Gaia theory. So Gaia theory is the idea that the biosphere co-evolves with the geospheres. They evolve together. So the life and the planet, the biosphere and the geospheres, evolve together to form a self-regulating, complex system that maintains and perpetuates habitable conditions on the planet. So it's the idea that in some sense, the Earth is kind of like a cell. That's not really what they meant, but metaphorically, that it's a complex system, and it's a complex system that can exert self-regulatory behavior. Okay, so next slide. So now the Gaia hypothesis was not something that science at the time when it was first proposed in the 80s, people were very happy with, scientists were very happy with. And in some sense, it was because of people like these two. This is Oberon and Maureen Glory Zell Ravenheart. And I'm sure they're very nice people, but I'm going to make fun of them. So they were both, I just found them on the internet. They're priests and priestesses of Gaia. So the thing about Gaia is the idea took hold. It became very new agey, that Mother Earth, we should all sing songs to her. And that is actually, if you look at this picture closely, that is a unicorn. Yeah. So somebody took a goat and glued a horn on its head. And so it was just that, so scientists, unfortunately, because of what happened, a lot of biologists and earth scientists saw Gaia as being this kind of new age woo idea. So, kind of got a bad name. But what happened actually was that the basic idea of Gaia, which is that the biosphere exerts strong feedbacks on the Earth, actually got complete. It's the foundation of climate science. You can't do climate science without understanding the biosphere. So, what happened was Gaia theory morphed into what we now call Earth Systems Science, ESS. And is now, so it's still not clear whether the biosphere really exerts full self-regulation. That may not be true, but that the biosphere exerts very, very strong feedbacks through networks, vast, deep networks of microbial and plant interactions, with the air and with the water. That part is, that's just like standard theory now. So that I'm going to use that as a background for what I'm now going to talk about. We'll go to the next slides. So, our proposal for planetary intelligence is that it had 5 properties. If you actually got planetary intelligence, it would have properties of emergence, information flow on networks, semantic information rather than just the usual information we use in computers, that it would be a complex adaptive system, and that it would show what is called autopoiesis. So let me quickly go through these. So emergence is just the idea that that systems, if they're complex enough, you can get new behaviors. You can get things that you couldn't predict from just looking at the atoms. Say, you can give me everything I need to know about atoms, and I still won't be able to predict a cell. Okay, so that you can planetary intelligence would be an emergent property of all the other lower level systems that go into it, that make it up. So now we go to the next slide. So information flow on networks. The idea would be that there's these chemical networks. There are the physical networks of mass being moved around by rainfall, and there's all these different chemical and physical networks that the biosphere is deeply part of, has created, and that it's information flowing through those networks. That's sort of how planetary intelligence manifests. The information flows through those networks. In response to that information, the networks change their properties, evolve, adapt, and that is how planetary intelligence, appears. All right, now we'll move to the next slide, which is that what's important here is that we're talking about information, but we're not talking just about what's the information in your computer. We're talking about what's called semantic information that has meaning. And I won't go into this in great detail. This is something we just got a big Templeton grant to study. But it's the idea that, information has to mean something to somebody in order for it to do anything. And so the idea is that the planetary intelligence, the planet as a whole, through these networks, responds to the information. There's meaning in the information, and that is what drives the changes in the systems. That has how the intelligence exerts itself. Now, we're not talking about like the idea that there's, the whole planet sits there and says like, oh, there's too much oxygen in the atmosphere, I better reduce it. That's not what we're talking about. We're talking about like sort of cognitive systems in the sense of there are systems by which the information can be recognized and acted upon. It doesn't have to be like conscious thinking. For complex adaptive systems, I'm not going to go into this at all, other than saying that, it's the complex systems. All of life is a complex adaptive system. And it's very different from just thinking about, it's not mechanics. It's not like just pure physics. There's much more going on. It's much richer. And it's the real frontiers of science. Okay, the last view here is what's called autopoiesis. So this comes from researcher like Francisco Varela, who established the idea that, one of the things that really makes life central, it's not just reproduction and genes, it's self-maintenance and self-creation, right? A cell has to create the membrane, right? Has to continually create and maintain the membrane, which is what allows the cell to continually create and maintain the membrane, right? The path for life has to continually, under precarious conditions, recreate itself and maintain itself. And so what we're going to say is like if a planet were to have intelligence, it would be autopoietic, and actually would have all 5 of these characteristics. So now, very briefly, I just want to talk about the idea. Let's apply these ideas to the Earth at different points in its history. So the first one is the idea that, life and the planet have been co-evolving for a long time. This slide just sort of shows you the different things that have happened with co-evolution. The biggest example is oxygen. When the Earth formed, there was no oxygen in its atmosphere. There was no oxygen in the atmosphere after life formed. There was no oxygen in the atmosphere for 1 billion years, at least, after life formed. It was only because of the invention of a particular form of photosynthesis that life started pumping oxygen into the atmosphere. And once that occurred, the entire trajectory of the planet changed. The chemistry of the rocks changed because there was so much oxygen. So the idea is that, the biosphere started off probably being what we would call immature. Originally, when life just got started, the biosphere there wasn't enough of the biosphere, and it hadn't evolved the feedback loops to be able to exert control over planetary evolution. But eventually, and then we'll go to the next slide now, eventually the biosphere matured, meaning it developed those complex network of feedbacks that it actually began to exert control. So this is when, after say 1 billion years, or who knows, 500 million years after life forms, you begin to get the first, example or instantiations of planetary intelligence, of this complex biospheric system responding to the planetary conditions and exerting some control over the biosphere. So I'm just going down the list here. I won't. Later on, we can go back and I can explain these slides to you. But this idea that there's an immature biosphere which matures into a mature biosphere, and the hallmark of the mature biosphere is planetary intelligence. So it's got all of, I'm checking off the boxes here, all those 5. The mature biosphere has all the characteristics that I said of planetary intelligence. So now let's go on to where we are now. So this is, I'll call it Act 2. So right now, just recently, over the last 100 years, the Earth has evolved a technosphere, and that's the sum total of all the interlinked set of communication, transportation, bureaucratic, and other systems that act to metabolize fossil fuels and energy resources. And so, it's the sum total of all the technological aspects of what we've created. And that, just like the biosphere, it's more any technology, the technosphere is much larger than any individual technology. And it's actually much larger than any individual human being. And we know that, look at all of the shipping routes, right? The world is crisscrossed by the activity of our minds. Right now, where you're standing, that room you're sitting in is literally permeated by waves of thought. And that is literal in the sense of the wireless communications that is flowing through your body in radio waves. Climate change is the most obvious example of the technosphere, of the impact of the technosphere, but you could go on quite a ways to talk about it. So the idea is, okay, we've got a technosphere, but now let's move to the next slide. It's an immature technosphere. So what I mean by that is, while our current early Anthropocene phase of planetary evolution, it has key features of planetary intelligence, right? I mean, there's clearly intelligence in the technology, but it lacks the most important part of planetary intelligence. It's not autopoietic. It's not self-maintaining. What we know is that the way the current technosphere is not set up to maintain itself. It's actually destroying the conditions it needs to survive, right? So what the biosphere learned how to do was be able to change the trajectory of the Earth's evolution to maintain the conditions it needed to exist, but that the technosphere is doing the opposite. It's actually destroying those conditions. So now let's go to the next slide. So the idea would be that we are right now in an immature technosphere that does not display the full complement of characteristics you need for planetary intelligence. So that's our problem, essentially. So, okay, so let's now go further. So let's think about both the human future and, in general, think about other civilizations on other worlds if they exist, right? So we're very interested in looking for what are called technosignatures, signatures of technospheres. This is something I am interested in working in. And the best way of doing this is not by looking for radio signals, beacons that some alien civilization has put out, like sending us a message that has the cure for cancer. The best thing to do is look for unintentional signatures. To look things that, like, civilization is just going about its business, being a civilization, and we can see planets now from across light years. Can we see their activity? And so, all right, let's go to the next slide. If we're doing that, what that means is if we're going to see other civilizations, you can work out the statistics, you're probably going to see older civilizations, much older than ours. So are there older civilizations? Well, the hypothesis is that if you're an immature technosphere, you're not going to make it very long. So in order to make it for a long time, the civilizations we're going to see must be mature technospheres that have developed the full property of planetary intelligence, where the technosphere has become embedded into the biosphere in a way that doesn't diminish the biosphere's capacity for existence. The technosphere has become autopoietic. So if we go to the next slide, so, a mature technosphere, so this is our image of a mature technosphere, right? It's a high-tech world that also is sustainable in terms of its biosphere. And it's got, it's got emergence and information flow, et cetera, but it's also autopoietic. It's also, the technosphere is not destroying the conditions it needs to survive. And what are those? That's the biosphere, right? Because the technosphere sits on top of the biosphere. So, so the idea is that just like there is a transition between a immature and mature biosphere in terms of planetary intelligence, there has to be a transition between an immature and a mature technosphere if technospheres are going to survive. And that's relevant to us, right? If we don't figure out how to have a mature technosphere or transition to a mature technosphere, we're not going to last long. So that brings us to the next slide. Is this the idea is, we've got these 5 properties. And from a pure geosphere where there's no life at all, 1 to a immature biosphere, mature biosphere, immature technosphere, mature technosphere, and the idea that they have different levels of these 5 properties, and the more you have, the more planetary intelligence you have. So the purpose of this graph was just schematically showing how we imagined this evolution of a planet with life on it how it might go in terms of planetary intelligence. So now, so this is just, we can come back to this when people ask questions, but this is just graphically the idea about how you go from an immature biosphere, which would be a world that, basically this is the, the Earth 4 billion years ago, to the top left, and then bottom left would be a mature biosphere. Top right is an immature technosphere. Bottom right is a mature technosphere. So just go to the last slide here. The idea is that where we're headed, where we need to head, is what I would call an awakened world, a world where the technosphere is, exerts the full capacities of planetary intelligence. Like, we know that we're intelligent, we have some degree of intelligence, and that is, manifested in our technology. But our technology, the technosphere we've built from it, is still stupid. It's not a smart technosphere. And if we're going to make it, we're going to need to embody, we're going to need to guide the technosphere so that it can embody planetary intelligence. So I'll end there, and I'll be happy to take questions for the next, 15, 20 minutes or so.
Well, thank you, Adam, so much. This was so interesting, and that's why I invited you. For me, another way to think about intelligence and the planet and life. So it's really exciting and interesting. I don't know if you know Howard Bloom.
Yes, I know of
He,
him.
I don't know that it's not it's not too similar, but some principles remind me a little bit. We had them here about how he thinks life kind of, or that there's a group evolution basically.
Mm-hmm.
It's different, but I don't know. I think there's this community kind of overlap thinking.
Yeah.
So.
You have to think about the whole system. You can't think about just the evolution of, individual species or there's group selection. This is really thinking about evolution on a much broader, canvas.
So do you receive, what's the feedback you receive? I imagine, because Howard described that he had a lot of, backlash thinking of what, while he, wrote his book. I don't know, what's the feedback you get?
I've actually gotten pretty positive feedback, which I was really surprised by. I thought everybody was going to be like, dude, you're smoking too much weed, or, like this is like you need to get off your meditation couch. But what's interesting, this idea has really, people and this just may be the nature of the community, in the astrobiological community. Even people who I would have thought would have been like, get out of here, have actually. So I have not yet received, I have not, the response. And we did the article in the Atlantic too. So this actually went, this went to the broader, it wasn't just in academia. We wrote an article for the Atlantic, which, got a fair amount of attention. So yeah, I'm surprised.
Well, I'm happy that things changed apparently, and you got positive feedback. That's wonderful. And instead of me just taking over, please raise your hand, ask questions in the chat. And I know Laniakas, you joined the stage. Did you want to ask a question?
Hi, thank you, Katerina. Always really interesting, the rooms that you have. Adam, congratulations. I think your work is amazing. What you guys are doing, I think, is great.
Thank you.
I think raising awareness around the ecological paradigm and a holistic paradigm is absolutely key. This is based on my personal research, but as an organization together, we talk about the evergreen shift, because what we found is when we're talking about density of communication, in terms of living systems, right?
Mm-hmm.
From the rainforest till now, it seems like the evergreen shift is the proof that nature has solved that a long time ago.
Right.
we've been trying to raise awareness about the same process and on in the cybernetic ecology, which I think you sum up as the technosphere.
Right.
And the reason we describe it as a cybernetic ecology is to raise awareness of the cybernetic science aspect
Right.
of its potential.
Right.
And so my question was, have you guys looked at this evergreen shift and seeing how because I feel like I want to ask you if you guys have, and I want to also invite you guys, would love to invite some collaboration here, because what we've been trying to do is essentially bring some awareness to the Homeland Security about what that means to for the future of cybersecurity, right? Because right now
Interesting.
we have an internet that is really an access internet. It looks at the grid kind of like a just a transmission system for
Right.
but really what we have is a cybernetic ecology where feedback is almost infinite, right? And we're putting sensors everywhere, and we have smartphones. So the minute we went mobile, we became a proper cybernetic ecology, because you're not just a static node, right?
Right. Right.
You're mobile, and you have wearable devices and cameras looking at behavior. So if you look at my bio, you'll see exactly what I'm trying to say. So I guess my question is, have you, considering how much work you guys do at the planetary level, if you've looked at the rainforest and evergreen shift as a way to help add
No,
specificity?
this is news to me. So if you could send me, I'd be happy if you would send me some information.
Yes, I would love. I
You know,
would
I'm a
love to.
I'm a big fan of cybernetics, of the idea of cybernetics. You know, Gregory Bateson is one of my heroes. So yeah, no, I'd like to learn more. Sure. So please, send me some information. I'd like to look at it.
I will. Your contact is on the document there, or?
Is it? I don't know. It should be. My email is
So
afrank20. Go ahead.
yeah, I can introduce you if when you just send me your email address, and I'll write the introduction email to both of
Okay,
you.
great, Katarina. That would be great. Thank you so much.
Great. Always looking for. I'm always happy when collaborations start from here.
Right.
It makes me really happy. So, Brent and Einar, please go ahead, ask your questions.
Hi, good afternoon, Katarina. Thanks again for another amazing guest and a great presentation, Adam. I was wondering what you make of what I think is probably one of the more far out topics in astrobiology and the idea of technosignatures, which is directed panspermia. What you make of this topic, thinking about planets, possibly as a sort of really large-scale organism. Would they want to potentially reproduce? We have some suggestions that certain types of fungal spores or tardigrades even can survive the vacuum of space, and just a lot of threads that I've heard about this topic thrown out there, and just wondering what you make of all of it.
Yeah, it's a really interesting idea, right? Can you extend this to galactic scales, right? And just like, if it did, you'd have the galaxy thinking over like very long time scales, because if there is, so panspermia would be the idea that you have there's directed panspermia where, if human beings were to go settle other worlds, right? If we were to settle, a planet around, Vega or something, that's directed panspermia on one level, right? You're actually, in some sense, what I always like to think about, I always like to say, if we ever settle Mars, it's not human beings settling Mars. It's Earth's biosphere settling Mars. We would just be the agents of Earth's biosphere, extending a green tendril, over to Mars and getting more Earth life on Mars. So I think so there's that idea, which is just a little bit more, easy to understand. You have intelligent technological species. But the other idea that you're sort of raising is that, with panspermia, regular panspermia, it's just that, you get an asteroid impact on Earth, and it blows a chunk of rock that's got microbes in it out of the Earth and out of the solar system, and then that rock wanders around with the spores, in hibernation, crashes onto another planet, and boom, you've got, Earth life there. When you look at that, you see that it is, at least the papers I've read, it's hard. Like it's the odds of really seeding planets this way with life, it's pretty rare. It would be a very, very rare event. At least what we can tell by how much, that when you try and work out the energetics and timing of things. But it is, I think it's a really, whether you're talking about the directed part where it's like actual, technology settling it, or the just the meteorites and spores. Either way, it can't be, you can't rule it out, and it's super interesting.
Thank you very much. And just one quick bonus question, if you don't mind. How would that go about being tested?
Yeah, see there, I'm not sure. Well, I'm not, unless you had that, it could be very hard. Unless, because what you'd actually need is to see whether or not the life on planet X and the life on planet Y that are, different stars had similar characteristics. If that did, then you'd be able to like, oh my God, they came from the same place. They have the same similar origin. And until you can actually go there and pick it up, that could be very difficult to finding life via biosignatures or technosignatures telescopically. You're not really going to get much information about the life itself. You're going to get the information about its effect on the planet, and that could be quite generic. But it's possible maybe you would see, you'd see alterations on the planet that are on planets that are, very specific, and you'd see them on very different planets, and that itself might indicate something like that.
Excellent. Thank you again so much for your appearance today, and Katerina for your hosting another great room.
Okay, I think you have 3 more minutes or so.
Yep.
Okay, so Einar, you have the last question.
Yeah, hi Katrina. Thank you very much. Hi Adam.
Hello.
I have 2 questions. So, if life formed when it comes to proteins and pressure, where does this come into the picture? And a more important question to me actually is like your thoughts around into this publication. Yeah, thank you.
Wait, I missed the first. What was? If you could repeat the questions again, I'm sorry, I just missed them.
So let's say that a protein, basically made under pressure, comes to where life forms and evolve. Any thoughts around that? And also the
Well, I guess what do
Kardashian
you mean by that? Like a protein? Are you just saying like so I just guess I don't understand. How would a protein? Are you saying that if you dropped a protein onto, like in a meteorite, say, a protein falls onto a planet that has life already?
Yeah, it's being created as a part of the chemical substances in a planet. Yeah, thank you.
Yeah, well, I guess it's not clear what form, so on Earth, life has, the molecular machinery is DNA, which makes leads to proteins, and the proteins are sort of the structures that sort of the scaffolding on which life is built, and the machinery that life uses. But it's not clear to me that I think probably life is going to be pretty ingenious, and probably there's going to be lots and lots of different versions of that. So I'm not even sure I would expect to see proteins anywhere else, other than the idea that proteins are sort of your building blocks may be very unique to how life formed on Earth.
That's very interesting, actually. Mm-hmm. Thank you very much. Yeah,
sure.
Thank you. But what about the Kardashev scale? Any thoughts?
Oh yeah. Right. Okay. So right. The my pronunciation of it is the Kardashev scale. So the Kardashev scale was this idea that as civilizations progress, they use progressively larger amounts of energy. So a type 1, uses all the energy that falls, solar energy that falls on the Earth. A type 2 would, basically build a sphere around, a Dyson sphere around the sun and capture all of the sun's energy. And a type 3 would capture all the energy from all the stars in a galaxy. That was an interesting idea, the Kardashev scale. I'm a little bit suspicious of it, just because it's sort of one reason. I'll tell you, on planetary scales, I think it's wrong because it's an energy-based scale. It only thinks about how much energy is involved, but it doesn't think about entropy, right? And as we've seen, if you tried to harvest all of the climate change, the Anthropocene, tells you that you can't harvest all of the energy that falls on the earth and put it to work because of the second law of thermodynamics. You generate waste and heat and chaos and disruption by using that energy. So I think one of the interesting lessons of the Anthropocene is that kind of pure energy. How much energy can we harvest? Just doesn't really work for planets. As I like to say, you can't bring a planet to heal, which is kind of that sort of 1960s version of the Kardashev scale. But you can probably bring it a plan, which is somehow you've got whatever you're doing with your civilization, you have to integrate into the biosphere, or else the biosphere will just bite you in the butt.
Thank you. But doesn't this mean that actually we as human beings think that in a, I don't know, pardon my English, but that we do think of energy in terms of physics in a different way, that we actually can extract the amount of energy?
Well, we're not
basically.
thinking. I
Because
think. Go ahead.
Yeah, because there are a lot of energy all around. You can basically in a palm, you can have enough energy to provide lights for a whole city if you know how to extract energy.
Right, but the second law of thermodynamics, this is what's interesting.
Yeah, and that's a
You can have all the energy in the world, but the second law of thermodynamics says you can't use all of that energy without having consequences. There are consequences to energy use,
Exactly.
and that's what the Anthropocene is all about: learning the consequences of our energy harvesting.
Exactly. So this means that what we're being taught in school does not really fit in.
Well, they need to add, right? You need to add the idea.
Yeah.
You need to not just talk about energy, but also entropy.
Yeah, of course, but this means that we are not really there yet, because
No.
we are learning different things when it comes to metaphysics and whatnot also. But yeah, thank you very much. Thank you.
Sure. Well, I should probably get going because I've got to get to my talk.
Yeah. So thank you so much for coming, and hope you come back one day.
Sure.
We could talk for hours, and we really appreciate you taking the time. Thank you.
Okay. Take care, everybody. Bye-bye.
Thanks. Bye, Adam. And yeah, thank you everyone for coming, asking questions, and happy Friday, happy weekend, happy Halloween, happy everything. We have a room again next Tuesday. So I hope I hear you all back, and it's with Dr. Holtz, talking about cytoplasmic phase architecture of the nuclear pore, which will be really interesting. He's a really nice person and scientist. And then we'll have James Weiss, who discovered very rare microscopic species. He has how many I don't know, a few tens of thousands of followers on YouTube. He makes really cool microscopy YouTube videos. Victoria and I checked them out, and he's an independent researcher. He has a really interesting life story. He's a screenwriter, usually does movies, but he has a passion for science, and he collaborates with scientists at universities, and he discovered a bunch of new species. So his life is really interesting, and his science. So yeah, I'll invite you, and I'll share on Twitter his YouTube channel, which has really cool movies, little videos about his research at home with his microscope at home. And then we'll have Dr. Oliver, who will talk about hydrogen production from water using aluminium nanoparticles. And then we'll have November 7th, Dr. Boyden at MIT. He's a very famous neuroscience technology developer who will talk about his work, how he develops tools that image and control the brain. He's a really big deal. Check him out, Dr. Ed Boyden. But he's very humble and very nice at the same time. So yeah, I'm looking forward to next week, and I hope to hear you all back soon. Happy weekend. Happy Halloween. Bye.
Thanks, Katarina.
Clay, I closed the room in 3, 2, 1. Bye, everyone.